Hello everyone, thank you for joining us. My name is Jari HURTTIA, I'm the CEO of Finnester.
And my name is HOKKANEN, I'm the CTO of Finnester.
And also the founder of the company. We will tell you about innovative fire protection coating for composites. Finnester Coating is a Finnish company established already about 15 years ago. We are placed in Lahti, Finland, which is about an hour north from Helsinki. And we are a smallish growth company. And our mission is to actually prevent the problems related to fire with composites. After the presentation, I hope you will remember that our red product group is an innovative and disruptive way to protect and enable making excellent composites without changing the raw materials of the composite, so you can make the best possible composites you want and then protect it with an external layer. We also have developed our method and way to work with the customers, because basically producing a new product requires a lot of collaboration from the material suppliers and the manufacturer of the end product. So we have a way to support the customer to make composite materials fire safe. So typically, when manufacturers make great composites, they perfect certain features. And a good composite has easily the problem that it burns. And then when composite manufacturers start changing the raw materials and making better composites for the fire or optimizing the composite for the fire, they have to compromise on other performance. So the composite is not anymore as good as they would hope. And our solution is to actually make the good composite and protect it with an external layer, so encapsulate the composite from the fire. Jari will tell a little bit more about how the technology works and what's behind it.
Thank you, Jari. So the products are called red, so that's a product portfolio that includes a base coat and a top coat. So this is a two-layer system of coatings. You need to have the base coat and you need to have the top coat. Why layers? Because layers will give you the optimal 100% performance. Like if you paint your car, you need to have a primer which has the best primer properties. Then you have your color, then you have your varnish for UV and chemical protection. You cannot have that in one coating, so you need the layered structure to get the best performance. So the top layer is always, it's called hybrid red. The red doesn't refer to the color of the coating, it refers to the fire. So that's a ceramifying layer, that's a ceramifying coating, meaning that it's a normal polymeric material when it's not exposed to fire, but when it is exposed to fire, it will turn to ceramic material. That's the top layer. The bottom layer, the base coat, that is the intumescent swelling property, a coating that when it's exposed to fire, it starts to swell. And there are three different options for different substrates, different processes. We can go into details later. Or you can visit our booth and you can ask more questions about those performance. But in general, it's a multi-layer technology, works the same regardless of the base coat. So on the left side, you can see the ceramifying layer on top, and then you can see the intumescent layer beneath, and then the non-FST fire smoke and toxicity composite as a substrate. So then on the middle, you can see that when it's exposed to fire, the base coat starts to expand, forming expand foam, and the top layer will transfer to ceramic. So it's before fire, it's ceramifying. After the fire, it's ceramic. Again, it's protecting the substrate really doesn't change. Or if you have smaller requirements, for example, ignition times or flame spread, you can only use the ceramifying layer on top. So it's a debatable of the standards you try to reach. It will prolong ignition times, it will reduce the flame spread, it will reduce the emission of toxic smokes. Of course, it will lower the heat emission, it will protect the substrate from thermal attack. Or maybe you can see on the right top bottom corner, you can see that the one test done with thermal runaway. So it's a 30-minute burn with 11,000 degrees on the outside, and the other side is the well stabilized approximately 200 degrees. So how actually red works, I can show you a small video where you can see it's a two-layer system here. This is on the standard composite, it's a blue color, hybrid red on blue color, and the pure red is on the top, bottom base coat, and there are some water droplets on the surface. You can see that it's a very hydrophobic, easy to clean surface. I will start the video. I hope it starts. No, it didn't. Yeah, so the video doesn't work. It went very well as we planned. So, but anyway, we can see this video in our website. Of course, come and visit to our booth, and we can show you the video on site. But actually, what happens when the fire comes to the surface? This is after the burn. So when the fire comes to the surface, it will start to ceramify, and in the same time, the temperature will go to the other side of the coating, and starts to swell, and it's protected by. I'm not touching anything. It's protected by a thermal barrier, and then the thermal barrier is protected by ceramic shield, ceramic bubble, and keeps it stable. So you can see after the burn, there's a silvery white ceramic layer surface on top. It's a hard, like eggshell protecting shield layer, and that's literally like an eggshell that will give you the stabilized situation where black expanded layer is underneath, which is soft but thermal resistant and isolating char. It will keep the temperatures under control. It will keep the temperatures of the composite well below TG. It will keep the long-term stable protection. It flatlines, stabilizes more or less. You can burn it for 30 minutes, maybe you can burn it for 5 weeks, and there's no real damage to the substrate itself. I mean, why coatings? So this is one question for the composite people. So the coatings will give you certain benefits that you normally cannot have without coatings. So gel coats, yes, but our system are coatings, so you need to do the coating work after the demolding of the product. So it's easy to process. I mean, just the normal standard painting. You can use standard tools. Everybody in every place have an industrial painter or car painter who can use the similar tools, the similar applications, no different in that. These are two-component systems, so you have a 10-hour pot life, very high solid, very low solvent content. You can easily spray for a whole day after the mixing of the batch. There are no actually toxic materials in there, so there's no fire retardants in the products that will cause any problems with like antimony or any halogens. These are room temperature curing systems, so you just paint big parts and leave it. You wait 2 weeks, it's ready to go as such, but it's a double curing system in the sense that in half an hour you have a tack-free, dust-free surface. These are the hybrid red coatings. They are inorganic, organic-based systems, so its durability comes from the inorganic part, but the organic part gives you the adhesion, gives you the flexibility, and of course the colors and gloss levels. The resistance, the fire resistance, you can see on the video that you can see later, but it will give you also, if you don't care about fire, these are very high performance coatings, even you don't care about fire. So there's UV resistance, there's scratch resistance, there's easy to clean properties, there's anti-graffiti, and other things. And of course you can have aesthetics. You can have a choice of colors you want, you can have different structures, the textures, different kind of variations on that, gloss levels, and of course the hard protecting surface gives you that easy to clean property. So there's no, usually fire protecting coatings, interset coatings get dirty easily, but in this case they are easy to clean. So you get all in one. Now we go back to the markets and I will handle this to Jari.
Thank you. So yes, a couple of words about the markets. Of course, new constructions, so new product builders are our main target, but coating enables also renovation projects. So when a old worn out composite needs to be refurbished, made to be used again and achieve the fire protection at the same time, it is possible using our solutions. We mainly work due to the standards and the requirements of the standards. We work a lot with rail industry and construction. The new energy solutions, hydrogen cylinders, battery enclosures, those markets are looking for solutions to look for lighter weight materials, new materials. Composites are, in many cases, the solution, looking for fire protection, and we are working together with them quite a lot. Also, the next generation kind of manufacturing methods, so 3D printing, natural fibers, recycled materials, and thermoplastics open a lot of needs for external fire protection. So those markets are also on our active market lists. We've collected a couple of use cases, case studies, where our solution has been used. FRP footbridges to replace the old metallic bridges with composite bridges. So we have our customer, Fibercore here, Martin, sitting in the almost front row. If you have questions related to this project or these products and a sort of a customer vision into it, please ask the questions at the Q&A. But basically, the bridge, when it needs to be put on top of a railroad, it needs to fulfill that industry standards. And there is fire requirements, coating with our hybrid red, the standard requirements are achieved. Then the railroad industry is looking for lighter materials, and composites are their preferred choice, also due to the recyclability. But those thermoplastics and recyclable materials burn easily, so external coating is a solution for those. Marine industry is also interest to us. We are at the moment not that actively working with them. Those are big markets, but we have a couple of cases ongoing and also one customer. So those rotor sails on top of the bridge, on top of the ship, helping to reduce the consumption of energy. So those are made from composite, and to fulfill the IMO standards, they are protected with an external coating. And then the next generation manufacturing solutions, the 3D printing. So those surfaces are typically rough. The rough surface can be smoothened using our primer coating hybrid flow, and then, which is an intumescent coating, and then the outer surface, which is always painted, because the 3D printed piece is typically not surface ready or ready for use. So they are coated. So coating it with hybrid red will provide the needed outlook. And to implement all these into the production, it's not only the technical conversation, it's also the business case, how to make it a viable commercial solution, and also how to integrate it into the end customer processes. It's a two-way communication, goal setting, and it's also a commitment from both sides. And we are willing to help all the customers needing this kind of support. So we are willing to help and work as a project to make it viable. For the technical part, we have our own fire lab where we can make technical tests for the material together with our composite. So it doesn't work so that the customer just puts the coating on top of it, it actually needs to be tested, the substrate together with the coating. Toxic fumes and smoke opacity we will do in an external laboratory, but everything else we can do indicative tests at our own lab, and then of course to make it standard fulfilling, making those tests at an external verified laboratory is needed. But anyway, this is the disruptive and innovative way to protect good high-quality composites against fire. If you have any questions, please feel free to ask. We are both here together with Jari to answer those. And if you want to ask the customer feedback, Martin is also. Please, gentlemen. They're bringing you the mic.
Hi, thanks for your talk. I'm Kevin from Velix, and many of these tests for fire, such as UL94, it's an edge test, and I could foresee that the flame would not be touching your coating at the edge instead of approaching it from the side, whereas much of your tests are orthogonal to the coating. So, 2 questions. What is the thermal insulation value of your coating after it intumesces? And how would you possibly test your materials so that you can get a more representative edge test than the UL94?
UL94 is a tough test. So UL94 is not suitable for our system because it's more for uniform, homogeneous plastics. If you have layered structures like we do, it's not going to work. To UL94, it will go when you put the fire on it. It will go between the interface of the as you mentioned. So UL94 is not suitable a reference test. So it's mostly for the surface, perpendicular to the surface tests, and like EN45505 or EN30501 or IMO tests, but not edge tests. So that's a tricky one. You got me there, yeah, that's right. Thermoconductivity, I mean, yeah, thermoconductivity on, for example, in hydrogen cylinders in thermal runaway, if you have 1100 degrees on an exposed temperature side, then on 3 millimeter into the composite, 7 millimeter into the composite, you can keep it about 230 degrees level after 30 minutes. It will flatline after 8 minutes to that level. So you can decrease about 700 degrees the values, the temperature values. Please.
Hi there. Thank you very much. My question is, what is the thickness of the coating? So in the example that you gave, the thermal runaway, what's the thickness? And then also, what's the thickness once it's intumesced?
The thickness is normally 400 grams plus 400 grams per square meter, so total 800 grams per square meter, which is a total weight. The thickness is approximately 0.6. That's the standard EN45505, 13501, but if you go to thermal runaway, you would need more base coat. So I would say totally 1 millimeter if you go to thermal runaway tests. Afterwards, it will expand to 3 to 4 centimeters. That's it.
Other questions?
We are on booth L40.
Yeah.
L40, so we have some samples, we have some videos that we can show that we didn't see today, but please visit. Okay, thank you.
Thank you.